Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथिरे मु ऑलरेडी प्लस टू सेकेंड इयर सिलेबस कंप्लीट कर सारी एवं मु प्लस थ्री CBCS फिजिक्स ऑनर्स जीई आ MSc फिजिक्स ऑनलाइन क्लासेस रो वीडियोस अपलोड करुच्ची जदि भल लगिला ताले वीडियोस को लाइक कर देबा और चैनल को सब्सक्राइब कर देबो यू कैन शेयर इट विथ योर फ्रेंड्स आल्सो इट्स कंप्लीटली फ्री ऑफ कॉस्ट लेटेस्ट वीडियो नोटिफिकेशन पई बेल आइकन को एठी ऑल रे सेट कर देबो तापरे वीडियोज रो क्लैरिटी बढ़ावा पई गो टू सेटिंग्स क्वालिटी एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन सबू वीडियोज पाई पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें बोस-आइंस्टाइन कंडेंसेशन ए विषय रे पढिबा सो इट इज related with the degeneracy ओके ताले आमे प्रीवियस क्लास रे आइडियल बोस गैस विषय रे पढिथिला जोथरे गुटे एक्सप्रेशन पाउथला फॉर द वैल्यू ऑफ a which was e to the power minus alpha and it is equal to nearly equal to n by v into h cube by 2 pi mkt to the power 3 by 2 right अच्छा ए एक्सप्रेशन रो जणा पड़छि जे if we increase the density of particle and or decrease the temperature ताले value of a also increases काहे because the value of alpha which is minus mu by kt decreases so the behavior of perfect gas departs further and further from the classical perfect gas due to the fact that ame quantum statistics रे velocity of particle को consideration को नहीं था which is not in case of your classical statistics. So the gas under this condition is said to be degenerate. आउ ए जो value a को आमे कहिबा degeneracy parameter. Okay. अच्छा ए जो expression आमे देखिबा को पाउछु a रे तीनटा variable रहउची गोटे हला mass of the particle small m आ गोटे हला particle density that is n by v बा या को आमे number of particles per unit volume कहि परिबा तापरे 3 नंबर रहउची absolute temperature of the gas that is T. So the criterion for the degeneracy will be based on the magnitude of n by v whole divided by mt to the power 3 by 2. Hence, the degree of degeneracy will be large when the temperature is low, first, when the particle density is large, second, and when the mass of each boson is small, third. Okay, so on account of above three factors, the gas can become degenerate in three different ways. Okay, acha. Now for low energy, the value of maximum admissible or allowed value of A is equal to 1 low energy पाई ओके एटा प्रीवियस क्लास रे हमें देखि दिला ताले हमें आ गोटे जिंस भी जानिछु जे अल्फा रो वैल्यू केबे भी नेगेटिव हेई परिबो नाही thus for low energy value the limiting case of highest degeneracy in case of your Bose-Einstein gas reaches केतेबेले when the value of A equal to 1 that is e to the power minus alpha equal to 1 or alpha must be equal to 0 because negative तो ही परिबनी then the maximum value of f1 alpha will be given by f1 alpha रो expression एटा भी previous class रो देखिबो pdf ideal Bose gas रो so this was the expression summation r equal to 1 to infinity a to the power r divided by r to the power 3 by 2 now the maximum value पाइबा पई हमें अल्फा जगह रे 0 पुट करबा आ ए जगह रे 1 पुट कर देले एबे ई समेशन को हमें जदी सीरीज हिसाब लिखि देले एति की आसीबो which is equal to 2.612 right so the maximum value of particle density n by v will be given by equation 15 equation एटा भी previous class रो आछि जो pdf हमें देखितिला ideal Bose gas रो so it was n equal to v by h cube 2 pi mkt to the power 3 by 2 into f1 alpha from which we are getting the maximum value n by v max equal to 2 pi mkt to the power 3 by 2 by h cube और f1 alpha जगह रे हमें f10 that is 2.612 पुट कर देला okay now a equation जो देखिया को पाउछो it is corresponding to the limiting case of Bose-Einstein degeneration okay and no solution of equation 15 can exist for the case n by v when it is greater than 2 pi mkt to the power 3 by 2 divided by h cube into 2.612 एई केस पाई किछि भी सॉल्यूशन आमे पाई परिबा नाही काहेकि बिकॉज इट वुड इन्वॉल्व द वैल्यू ऑफ a which should be greater than 1 ओके आमे तो इक्वल टू 1 नेचु तेणु आमे सॉल्यूशन ए केस रे पाई परिबा नाही so the fact that no value of n by v can be greater than that given by equation 32 can alternatively expressed in terms of a critical temperature that is T0 এই alternative expression रे आमे n by v को जदि लिखुछु that is 2 pi m k T0 to the power 3 by 2 by h cube into 2.612 ताले T0 रो वैल्यू अकॉर्डिंगली एतिके आसी गला ओके सो आमे कहि परिबा क्रिटिकल टेम्परेचर माने कोन इट इज द लोएस्ट टेम्परेचर फॉर व्हिच अ सॉल्यूशन ऑफ इक्वेशन 15 is possible that is there is no solution of equation 15 when the temperature is less than the critical temperature T0 so T0 is therefore the temperature at which the degeneracy of the energy levels starts okay जो जगारू degeneracy आरंभ हुए so एबे जदि हमें प्लॉट करिबा गोटे ग्राफ बिटवीन द एनर्जी एंड द टेम्परेचर T of the gas then we'll get a curve as shown in the figure तो एठी तमे फिगर रे देखिया को पाउछो दिस इज योर क्रिटिकल टेम्परेचर T0 okay below this critical temperature here the full line it is showing the relation between E and T for the degenerate gas okay while this dotted line which is passing through the origin is showing the behavior of your non degenerate gas एठी E0 कोन it is called as the 0 point energy which will be understood जोटा हमें फर्मी डिराक स्टैटिस्टिक्स रे बुझितिला ओके बा को देखिबा नाउ द क्रिटिकल टेम्परेचर T0 जदि हमें पर्टिकुलरली गोटे बोस गैस नेबा धरो हीलियम ओके हीलियम गैस पाई T0 रो वैल्यू हला 5 केल्विन नाउ the question arises why there is no solution of equation 15 for the temperature less than critical temperature T0 काहेकि एमती होची because while arriving at Bose-Einstein distribution here the closeness of the energy levels एटा जो energy level रो closeness टा आसी जाउची बढ़ी जाउची so we have assumed continuous distribution in place of your discrete distribution तेणु we have replaced the summation by integration while at low temperature the number of particles begin to crowd into the lower energy level which is generally the ground state okay because आमे जानिछु Bose-Einstein statistics रे बा गोटे Bose gas एटा पाउली एक्सक्लूजन प्रिंसिपल ओबे करे नाही तेणु करी गोटे पार्टिकुलर स्टेट रे जेते संख्यक पार्टिकल भी रही परिबो सो एठी लोएस्ट state by lower energy state jodi ame kahiba which is supposed to be a ground state then a large number of particles may occupy in the ground state having E0 equal to 0 so this means at low temperature we must be careful in replacing the summation into integration okay acha ebe ame जो नंबर अच्छी पार्टिकल रो नंबर ऑफ पार्टिकल्स बिटवीन एनर्जी रेंज E एंड E प्लस D ताकू जदि लेखिबा इट वाज NEDE इक्वल टू GEDE डिवाइडेड बाय e टू द पावर अल्फा प्लस E बाय KT ओके अच्छा ताले एठी GE रो वैल्यू केते थिला 4 पाई mv बाय h क्यूब इनटू 2me टू द पावर 1/2 now it may be now noted that the ground state where E equal to E0 equal to 0 here the value of GE will be how much निहाती भाव एठी E जगह 0 पके देले G रो वैल्यू भी 0 आसी गला while actually it should be unity हेबा कथा ground state रे okay G0 equal to 1 काहे कि as there is one state at E equal to 0 गोटे स्टेट तो रहउची ना therefore above distribution that is given in equation 35 gives incorrect result for the case of your ground state okay ground state पाई एटा incorrect result दोची okay 0 देखौची किंतु actual रे 1 हेबा कथा okay while this state is very important at low temperature so further we note that in case of your value of energy जदि it is not equal to 0 E not equal to 0 हेले GE be not equal to 0 हेला and therefore above distribution holds good so को जगह रे incorrect आछि जो जगह रे E equal to 0 ground state रे okay so consequently the distribution 35 equation can still be applied for all states except ground state, okay, which should be treated separately. So for the single state, suppose I nela ith state, তাহলে ni ହେଇଗଲା gi by e to the power alpha plus beta ei minus 1. Now ground state ପାଇଁ ei equal to e0 equal to 0. Now as we have seen, it has only one state, so gi equal to 1. So therefore the number of particles in the ground state are given by n, which is tending towards n0 equal to 1 by e to the power alpha minus 1. Therefore the total number of particles, that is n, for the degenerate case may be now expressed as the sum of number of particles in the ground state then the number of particles in the excited state, right? So ଏଇ जो इंटीग्रेशन रे थिबा NEDE उपरे वैल्यू आमे पाइथिला ताको आमे पुट कर देला, राइट? आउ ए टोटल इंटीग्रेशन जोटा रेंज करची फ्रॉम 0 टू इंफिनिटी, ए टोटल टाको आमे कहिला कोन याको गुटे रिप्लेसमेंट आडिला n प्राइम बा n डैश रे, ओके? सो n प्राइम इज नथिंग बट दिस मच, राइट? अच्छा, सो एतिकी पाइला परे आमे देखिला जे n इक्वल टू n0 प्लस n डैश, ओके? अच्छा, एई थ्रू एबे आमे जो n प्राइम रो वैल्यू लेखुतला आमे देखो ए इंटीग्रेशन रे तमे देखिया को पाउछो याकू एबे आमे जदि भल से देखिबा रिप्लेस करि परिबा बाय यूजिंग द वैल्यू ऑफ f1 अल्फा, ओके? सो इट वाज फाउंड आउट टू बी इक्वल टू v by h cube 2 pi mkt to the power 3 by 2 f1 अल्फा. फर्दर आमे इक्वेशन 34 को देखिबा, ओके? ऊपर जो इक्वेशन टा देखिया को पाउतलो वेयर यू आर कैलकुलेटिंग द वैल्यू ऑफ n by v in terms of your f10, ताले एठी t to the power 3 by 2 आउ f1 अल्फा को खाली रखी दबा, बाकी जतक टर्म को रिप्लेस कर दबा, ओके? देन इट्स वैल्यू विल बी n into 1 by t0 to the power 3 by 2 into 1 by f10 हबो, ओके? चेक करिवो, राइट? where f10 is nothing but 2.612. आउ आमे जानिचु f10 ही होची मैक्सिमम वैल्यू, तेणु करी एटा f1 अल्फा रु निहाती भाबरे बड़ हबो. Therefore n dash, which is given in equation 14, acquires its maximum value when alpha is equal to 0. Thus the maximum number of particles n dash occupying states above the ground state will be now given by n dash equal to n into t by t0 to the power 3 by 2, right? अल्फा में 0 पाई ही हमें देखुला जे मैक्सिमम वैल्यू, सो एई टर्म जो रेशियोटा हमें काटी देला, ओके? को जाय रे ना when the temperature is less than t0, right? So the rest of the particle, बाकी जेते पार्टिकल एबे बचिले ताको हमें लिखि परिबा ग्राउंड स्टेट रे थिबा पार्टिकल which are n0 equal to n minus n dash. So value put कर देले n into 1 minus t by t0 to the power 3 by 2 for the lower temperature, that is t less than t0. So एतिकी जो particle ground state रे रहिले they must condense, okay? They must condense. So from equation 42 it is obvious that when the temperature of a Bose-Einstein gas is lowered below the critical temperature, that is T0, the number of particles in the ground state rapidly increases, and this rapid increase in the population of the ground state below the critical temperature here, which is taken to be T0 for a Bose-Einstein gas, is called as the Bose-Einstein condensation. याकू ही Bose-Einstein condensation कहा जाए. And it is obvious from equation 34b that the critical temperature T0 at which Bose-Einstein condensation actually starts depend upon the particle density, that is n by v, okay? So a equation 42 को हमें plot करि परिबा in a graph where we have taken the fraction of particles which are condensed in the ground state for t less than or equal to t0. So देखो एठी x axis रे हमें t by t0 नहीं गला आ y axis रे n by n0 नहीं गला, ताले सिंपली ग्राफ टा ए बळिया आसीबो, ओके? सो मैक्सिमम ए जगह रे रहउची, ए जगह रे भी t by t0 माने जो जगह रे t equal to t0 आसी जाउची n by n0 0 ही जाउची, राइट? सो एट द ग्राउंड स्टेट where E equal to 0, the particles of a Bose-Einstein degenerate gas condense in the ground state and they do not contribute to the energy. Okay, and for temperature above the critical temperature, that is T0, ଆଉ ଏବେ alpha ର value 0 ହେବ ନାହିଁ. So the number of particles is given by equation 15 with the negligible number of particles in the ground state and the gas is said to be in the classical or non-degenerate state. Okay, so in case of helium in liquid state, T0 can be calculated to have a value of around 3.12 Kelvin, and therefore the degeneration and condensation of helium must start at 3.12 Kelvin. किंतु experimentally देखा जे lambda point transition liquid helium ପାଇଁ condensation show करुची around starting at 2.19 Kelvin, which is very much close to the calculated value. So below this temperature, the liquid helium exhibits remarkable physical properties of a superfluid, and it is generally believed that lambda point transition is observed in the liquid helium at 2.19 Kelvin, and it is essentially a Bose-Einstein condensation. So fundamental importance Bose-Einstein condensation is the explanation of the phenomenon of superfluidity. Superfluidity माने कौन? It is the property of the liquid helium at very low temperature that enables it to flow without friction. So both the isotopes of helium possess this property. Suppose I am helium 24 nejiba, tale it becomes superfluid at 2.172 Kelvin, whereas helium 32 it does not become superfluid until the temperature of 0.00093 Kelvin is reached. So at very low temperature, around 2 into 10 to the power minus 7 Kelvin, a Bose-Einstein condensation can form, in which several thousand atoms become a single entity. ଆଉ ତାକୁ ଆମେ କହିବା super atom, right? And this effect has been observed with atoms of not only your helium but also rubidium, lithium. So superfluidity and superconductivity has a similarity, and sometimes a superconductor is called as charged superfluid. Okay, so up to this I have taken the Bose-Einstein condensation from one book. This I have taken from another book, but however এই বইরে ইয়াକୁ ବହୁତ shortcut way ରେ ଦେଇଛି. Okay, ଏତେ detail या ବିଷୟରେ expansion କରିନି. Okay, you can read from this book also, right, and make your note accordingly. Okay,
Thank you.